This Python code snippet imports various libraries commonly used for manipulating, analyzing, and visualizing data, including a specific library for scraping cryptocurrency data. These include DataFrame for working with dates and times, NumPy as int for numerical computing, Pandas as step for data analysis and manipulation using data frames, and Matplotlib. Pyplot as approach for creating visualizations, and CryptomChain scraper for scraping cryptocurrency data from CoinMarketCap. The code sets up the necessary environment for performing tasks related to handling dates and times, data analysis, scientific computing, and visual representation of data, with a focus on cryptocurrency market data. This code creates a scraper object using the mScraper class in Python. The purpose of the object is to collect data specific to Ethereum ETH from CoinMarketCap, a platform for tracking cryptocurrency capitalization. Passing ETH to the mScraper indicates that the scraper will gather information about Ethereum. Note this assumes the presence of a mScraper class with this functionality. Based on its name and parameter, the actual class definition is not provided. The provided Python code illustrates the visualization of Ethereum's closing price history through a line chart. The code creates a figure and subplots, plots the close column against the DataFrame's index, adds a title and labels, and displays a legend. This code is typically run in an interactive environment, such as a Jupyter notebook, to view the resulting chart. This code in Python uses the relative strength index RC to evaluate overbought or oversold conditions in an asset. The steps are as follows. 1. Calculate the difference between consecutive closing prices using the close column of a data frame if. 2. Remove any notch values that occur from the first element. 3. Create 2 copies of the difference series for positive and negative changes. 4. Replace negative values in the SHUP series with 0 and positive values in the SHOUN series with 0. 5. Define a period, typically 14 periods. 6. Calculate the average gains and losses over the defined period using a rolling window mean. 7. Convert the average losses to positive values. 8. Calculate the relative strengthers by dividing average gains by average losses. 9. Users to compute the RC, which is scaled between 0 and 100. 10. Result allows for visual assessment of overbought RC over 70 or oversold RC under 30 conditions in the asset. The Python code creates a new data frame called newDFA and adds 2 columns, close price and RC, to it by pulling data from another data frame and variable computation. This Python code creates a graph for the relative strength index RC, which is used in financial analysis. Each line of the code has a specific purpose, such as setting the figure size and title, and plotting the receive values from a data frame onto the graph. Horizontal lines are also drawn at certain C values to represent oversold and overbought thresholds. The final result is a visual representation of the RSEC over a time frame, with easily identifiable threshold levels. The Python code examines a data frame named newDFA and generates buy and sell signals based on predefined RSEC thresholds. It creates 2 lists, buying signals and selling signals, to track these signals. The code works in the following steps. 1. It initializes a flag to 1 and creates 2 empty lists for storing buy and sell signals. 2. Iterates through each row of a newDFA. 3. If the receive for a row is below or equal to 25 and the flag is not set to 1, it is considered a buy signal. The corresponding close price is added to the buying signals, while a placeholder is added to selling signals. 4. If the RSEC is above or equal to 65 and the flag is set to 1, it is treated as a sell signal. The corresponding close price is added to a selling signals, while a placeholder is added to buying signals. 5. If none of these conditions are met, or if the flag prevents a signal to avoid consecutive buy or sell signals, placeholders are added to both lists. 6. The flag is updated based on specific conditions to ensure the alternating pattern of buy and sell signals. At the end of the loop, the buying signals contains the closing prices for buy signals, and the selling signals contains the closing prices for sell signals. Any indices without a signal are represented by placeholders. This code can be used for visual analysis and backtesting of trading signals or for implementing algorithmic trading rules. This Python code creates a visual representation of financial trade signals using the Matplotlib library. It plots closing prices from a data frame called newDFA with the label close price. It also identifies potential buying and selling opportunities based on momentum by scattering green triangles for buy signals and red triangles for sell signals on the chart. The code adjusts the transparency of the plot line and adds a title, labels, and a legend for clarity. The resulting chart is displayed using the show function. This piece of Python code uses the close prices from a financial dataset to calculate two exponential moving averages a short EMA and long EMA, with spans of 12 and 26 periods respectively. It also calculates the moving average convergence-divergence MAD line by taking the difference between long EMA and short EMAs, and then computes a signal line by finding the EMA of the MAD line with a span of 9 periods. These lines are commonly used in trading to detect changes in market momentum and can suggest buying or selling opportunities. This Python code uses the matplotlib library to create a graph of the moving average convergence-divergence MAD stock market indicator. The graph is set to a size of 14.5 inches by 4.5 inches and titled MAD plot. Two lines are plotted, the first in red to represent MAD values and the second in blue for signal values. The x-axis is set using data from the index of DataFrame diff. A legend is included to distinguish between the lines, and the graph is displayed using show. In Python, the pandas library is commonly used for handling and analyzing data. This code creates a new data frame named newDif, consisting of 3 columns MAD, signal, and close. The data for the MAD and signal columns are retrieved from variables named shmat and signals, while the information for the close column is taken from another data frame labeled chidf. This code essentially arranges these data elements into a table format with designated columns. The code is going through a data frame and comparing the MAD and signal columns to determine buying and selling signals. The signals are recorded as a list of prices or non-values. The flag variable is used to ensure only one signal is recorded. Setting it as 1 acts as a switch to track the last action, 1 for buy, 0 for sell. Based on the MAD and signal values, the code appends close prices to buying signals or selling signals lists and adjusts the flag accordingly. If no clear signal is present, none is added to both lists. This produces 2 lists of prices for buying and selling signals, as well as non-values where no signal is present. This Python code displays financial data using a time series chart with buy and sell signals based on the MAD indicator. It creates a figure with specific dimensions, plots the closing prices from a given data frame, and adds markers for buying and selling signals. The y-axis is labeled with the currency and a legend is included. The end result is a visual representation of trading strategy suggestions for a specific asset. This code in Python computes several exponential moving averages EMAs for the close column in a data frame called JDIF using various time spans. EMAs give more weight to recent data, and in this case, 4 EMAs are calculated 9, 13, 21, and 55. These refer to the number of periods used for the calculation, such as 9 periods for length and 55 periods for length. The EMA is set to not adjust its starting point with the adjustFalse parameter, making it more sensitive to recent price changes. The results are stored in separate variables length2, length2, length3, length4, and can be used for further analysis, such as trading strategies or technical analysis. This Python code uses the matplotlib library to create and display a plot titled forMaPlot. It plots 5 lines representing different data, including a close column from a data frame and 4 exponential moving averages EMAs for different lengths. The lines are displayed in specific colors and with a semi-transparent effect. After setting up the plot, it is then presented to the user. These lines are commonly used in financial analysis. The following Python code creates a new data frame named newDif, which is initially empty. It then copies the close column from an existing data frame, diff, and adds it as a new close column in newDif. This effectively extracts the close column from diff and creates a new data frame with only that column. The Python code detects buying and selling signals based on certain conditions. It iterates through data points and records the signals in separate lists. The conditions include checking the order of elements, changing a flag for buying or selling, and appending non-values for placeholders when no signal is found. This code may be used in a financial analysis or trading strategy using historical data and indicators represented by the arrays. The Python code is using matplotlib, Pplot to create a financial chart showing trade signals based on the 4-period exponential moving average formula. It begins by creating a new figure with specific dimensions and titling the chart. The close price from a data frame is then plotted as a line graph with an opacity of 0. 7. The chart also includes scatter plots for buying and selling signals, differentiating them with green and red triangles. The y-axis is labeled and a legend is added for clarity. This code is useful for analyzing financial data and displaying closing prices over time with potential buy and sell signals.